Hi again. Well, in the last video, we did an overview of one example of a hypothesis test. So now I want to break down some of those important pieces and talk about how to set these up, okay? So, and in general, in our class, we're going to be testing hypotheses in 5 different scenarios, okay? And for one parameter, which is what we're doing right now, there's 3 different options, and 2 of these are kind of similar. These are both P, and then a mean is mu, as we've seen before. So a process probability is something like the one we just did, where we're testing it against like flipping coins, or some other. It doesn't have to be 50-50. It could be 1/3, 1/3, 1/3, like rock, paper, scissors, or something where we're testing against a random process. And then we'll see there's another type of proportions where it's a specific proportion has been specified, sometimes from previous data or something else, or some kind of goal. And then means for numerical variables. Okay, and then this corresponds to, I was showing you too, the stat key applets. There's the test for single mean and test for single proportion. Then a little bit later on, we'll get into 2 parameters. So with 2 parameters, this is really cool because now we can compare 2 groups, right? So maybe we want to compare adults with teens, or men with women, or there's lots of different groups we can compare. So again, with proportions, we can compare the difference of 2 proportions if it's a categorical variable, or the difference of 2 means if it's a numerical variable. And there is a difference if you're comparing 2 different groups versus one group twice. Like say you're doing a before and after, like in an experiment, a before and after test. That's a little different because you have less variation with the same group twice than you do with 2 completely different groups. So that's a little bit beyond the scope of this class. So that's why I wrote difference of 2 groups is what we're going to do. And difference of 2 groups. We'll get more into that later on. Then there's an app for that, the test for difference in means and the test for difference in proportions. We're not going to do slope or correlation in this class. I believe that's in Stat 244, or if you go on to take other statistics classes, you might get to do that there. It's the exact same principle. It's not that we couldn't do it, it's just that you can only do so much in one term. Okay, so that's a little overview of all the testing that we'll be doing in this class. Now I want to go in more specific into that first part that we did with the Kiki Booba, which is writing out the hypotheses. Okay, so I want to explain more about the null and the alternate hypotheses. So the null is N-U-L-L, and it's written H0 with a 0 in the subscript. And you could pronounce that H null or H naught. Naught is another word sometimes used in math for a 0. And so that is that's like the accepted value, the status quo, or no effect. Okay, it's like what's commonly believed to be true, or it's it's our baseline assumption. Like in Kiki Booba, our baseline assumption was that there's no association between the words and the shapes. Okay, and the way we write that out, so we write H naught or H null with a colon, and then we put our parameter and the null value. Okay, so I've given general terms here because we have different symbols, right? So we might want to write this as, and let me check if I have it down below. No, I don't have it below, so let me write it out here. So we could write, if it was a proportion, we would write H naught and P equal to, I'm just going to use 0.5 that we did in the last one. That's one example. And this 0.5 is called our P naught. If we put the 0 on the P, then we're saying that's the value in the null hypothesis. Okay. Now, if we had a mean, we could write it similarly. We could write H naught colon, but this time it would be mu equals, and probably wouldn't be a 50-50, so I'm just going to say like 10.25. I'm just making up a mean. I'll say inches. And then similarly, this would be our mu naught. That if we want to refer to that value, we're saying that's the value under the null hypothesis. Okay? Okay, so that's how we're going to write out our null. And the other thing you might notice is it always has an equal sign. The null, we're always saying, is equal to a certain value, okay? And that's easy to test because we can make our randomization distribution using that value of 0.5 or say 10.25 inches. We set that up with our distribution, okay? Now our claim is the alternate. That's the claim that we're looking to show evidence for, or the thing we're trying to prove, okay? But keep in mind, we can't really prove anything. We can just show evidence for. So this, in this section, I feel a little bit like a lawyer about, like, there's certain things you can say and certain things you can't say. Can't really say you've proved anything, but we can say there's evidence for the claim. Okay, so usually we write that H sub A. So there's an A in the subscript. Sometimes lowercase, so I pronounce it HA. It could be H sub A with a lowercase a. Sometimes you also see it as H1, like H0 and H1. So you might see a combination of any of those. And now there's 3 different options for the alternate. And this corresponds to what you've seen on the app with right tail, left tail, and two tail. Okay, so if we're looking at our parameter as being larger than some value, then that's, as compared to being equal, then that's a right tail test. And if we're looking at our parameter being less than a certain value, that's a left tail test. And if we're just saying it's different, it's not equal to this value, then that's both tails. So that's a two tail test. Okay. So similarly, we could write out, I'll just write one of them. I'll stay green for the alternate. So I could write HA P is less than 0.50. Or I could write HA mu is greater than 10.25 inches. Notice I wouldn't put the equal sign in any of these because the equal is in the null. So it can't be both places. It's either equal or not, right? So it can't be in both places. So it's got to be in just one or the other. And then I could use the not equal sign as well. Okay, so that's the first thing we do. And remember, before we want to take any data or anything in real life, we would form our hypotheses first. It's not fair to get your data and then set up a hypothesis based on your data, right? Hypotheses first. We would write this out, but it's kind of interesting in a stats class because you usually have all the information you're given to start with, so it feels like you have everything at the same time. But really, in our process, you would write out your hypotheses first, then you would go about taking data. Okay, great. Okay, so now I want to go through the steps, and you saw this with the Kiki-Booba test, but I want to show you all the steps that we're going to do in a hypothesis test. And then I've got an example of each of these that we'll go through. We've got a right tail, a left tail, and a two-tail test, okay? So, steps to a hypothesis test, and we're using simulation here. There's also a theoretical method, which we'll do later on, but this is for the randomization distribution. Okay, so our first step is to write the hypotheses. Write the null and alternate hypotheses. Then we're going to simulate the null hypothesis with a randomization distribution. And that does, even though we're setting up our hypotheses in advance, we also need to know the sample size in order to make that randomization distribution. As we've seen, larger sample sizes are going to give a wider distribution, and smaller sample sizes will give a wider distribution. The bigger your sample size, the less sample-to-sample variation you'll have, so the narrower your distribution will be. So the sample size does matter. Even if you didn't have your data yet, we would need to know what the sample size is to make this randomization distribution. Okay, so then from our randomization distribution, we're going to find our approximate p-value. And the reason I'm saying approximate is we've seen it varies from simulation to simulation, so we won't all get the same answer. And then to show our work for this, we're going to put in an image or a screenshot of this randomization distribution that shows the p-value there, because that's how we're going to show our work. Then there's a new part I haven't told you about. We're going to compare the p-value with the significance level alpha. And we're going to use that to determine whether the result is statistically significant. We kind of did that by intuition, saying a really small value is significant, so I'll make that more precise. And then the last step, so 5 steps, state the conclusion in context. So we want to include the p-value and whether we reject the null or fail to reject the null. And then that context is so important, right? Because we can't assume that other people will understand what we're doing and what this all means. So we need to write it out as in the context. What is our conclusion in the context? Okay, so those are the steps and a little bit about the setup part. So in the next video, I want to start another example, and I'll go through the writing hypotheses and the first few steps, and then I'll tell you a little bit more. I haven't told you everything about this last 2 steps yet, so we'll come back to that as well. But it's a lot of information all at once. So let's go ahead and look at another example, and I'll see you in the next video.